Hi, good morning guys. This is Dr. Sajja Suneel from Data Science Department. Today I'm here to discuss you about few things which are dependent on web servers of IoT, cloud for IoT, and Python web application framework for designing a REST web API. These are the topics which I am going to discuss today. As I told you in my previous class, I'll come with an important topic which is this one only: web server for IoT, cloud for IoT, and Python web application framework for designing a RESTful web APIs. These are the topics which I am going to discuss today. And before discussing about this topic, you guys need to know what kind of objectives and outcomes which are designed for these particular IoT components which are used for web development. Web server for IoT. The main objective for this web server for IoT was you need to understand the specific requirements, you need to identify the suitable web servers, you need to learn how to configure a particular web server was. And the outcomes which you are going to know from this web server was you are having an ability to select an appropriate web server technology, you are going to have some skill how to configure these web server, you are having a knowledge by using the optimization techniques which are designed for this web server. And coming to the cloud for IoT, the main objectives are you are exploring different kinds of cloud platforms and services which are relevant to our IoT development. And also you guys are understanding the benefits of using clouds in IoT solutions. And you guys are learning how to interrogate these IoT devices and application with cloud platforms. At the end of this particular topic discussion, you are having an ability to select a proper cloud services, and you are gaining a little skill about integrating these IoT devices and applications with cloud platform. And also you are knowing about the knowledge of IoT development and deployment, guys. And Python web application framework. The main objective of this framework was you need to understand what kind of role this Python web framework was playing in IoT development. You need to learn the core concepts which are popular on Python web framework. You need to develop web applications for IoT data management and visualization. And with this, you are getting some ability to choose what kind of Python web program was used in IoT project. What kind of skills are developing in web applications of IoT data handling. What kind of knowledge we are getting by using these IoT device and web applications. And the next topic was designing RESTful web API. The main objective was here you need to understand the principles of RESTful API. You are also learning how to design this particular RESTful API and also the implementation of this RESTful API using Python web framework. After successful completion, you are gaining the ability to design RESTful APIs in IoT data access and control. That was the first thing. And coming to the second one, you are improving your skills in implementing RESTful APIs by using Python, and you are having knowledge about these API security with the best factors. By knowing about these four topics individually, you can effectively develop and deploy different kinds of IoT solutions which are creating a leverage to the power of cloud computing and web technologies in our IoT projects. What a web server in IoT was, you need to understand, guys, this web server is in IoT condition, which is a specialized software application which acts as a bridge between the IoT devices and the digital world, where we are collecting the information, we are processing the data, and we are analyzing the data with the connected devices and make it accessible to the users and other system. And this raw data is going to be in actionable information. That is what a web server was. What are the key characteristics? It is having a real-time processing IoT device which generate data continuously. So the web server is going to handle all the incoming data streams very effectively. And coming to scalability, there are different kinds of connected devices which can fluctuate, so that web server is going to handle the different kinds of loads inefficiently. And coming to security, a sensitive nature IoT data where robust security measures are essential for it, so that security is going to be improved. And low latency, different kinds of application require different kinds of processing time responses, where low latency is very crucial. And coming to resource efficiency, these devices have limited resources, so that web servers should be optimized for performance and memory usage. What are the different kinds of IoT web servers? Embedded web servers, cloud web based web servers, edge servers. embedded web servers, cloud-based web servers, edge servers. These are the different kinds of web servers which we have. Coming to embedded web server, which is designed by using resource-constrained devices, which can directly run on IoT device itself. The best examples are ESPS 8266 and ESPS 32, which are built-in web servers, which is embedded web servers. Coming to cloud-based web servers, these are the powerful servers which is hosted by data centers and handles a large amount of data. The best examples are Amazon EC2 and Google Compute Engine and Microsoft Azure. This was the cloud-based web server. Recently, you guys have seen the Air department system has hanged due to the failure of this web server. And coming to edge services, a hybrid approach, edge services are deployed closer to IoT devices, which reduce the latency and network traffic. These are the different kinds of web servers. What are the challenges and consideration which are facing in web server? Data volume, data format, security threats, real-time processing. Data volume. IoT generates a large amount of data, which requires efficient storage and processing. Data format, what kind of data it was, whether any kind of standardization was there or not. And security threats, vulnerable to attacks, so that web server must be implement strong security measures. And you need to ensure low latency and timely data processing is crucial. What are the different kinds of use cases which are presented in web server? The first use case was remote monitoring and control. We need to control the IoT devices remotely through a web server. Data visualization, we need to present the collected data in a user-friendly format. Data analysis, we need to process and analyze the data to extract the valuable insights. Integration with other systems, we need to connect with IoT data with enterprise system or cloud platforms. These are the different kinds of use cases which are related to web server. With this, I can conclude that these web servers are going to be used effectively in IoT applications and also in organizations which can select and configure the appropriate web servers to build a robust and scalable IoT solution, guys. And coming to the cloud for IoT, what cloud for IoT was? It is a comprehensive platform which enables the connection, management, and analysis of IoT device and data. And I can say you one thing, this cloud for IoT is a necessary infrastructure as well as the service and tools which are used to build and scale the IoT solutions very effectively, guys. And what are the core components which are existed? Device management was the first thing. Why? Because we need to handle different types of components. We need to know what kind of provisioning, what kind of configurability, what kind of firmware updates, what kind of service management is taken care in device management. And data investigation, there are various forms of data and various protocols will be there. We need to ensure an efficient data transfer. And data storage, a vast amount of data is going to be stored in cloud, whether it is reliable or not. It is going to store it is going to support both structured data, unstructured data, or mixed data or not. We need to verify data processing and analysis, which offers different kinds of tools and security for processing, analyzing, deriving insights in IoT data. And coming to application enablement, which provides the development environment, API, and other resources to build IoT applications. Security, which incorporates the robust security measures to protect IoT devices, data, and applicants from threats. And coming to the benefits of using this cloud for IoT, scalability is going to be improved by accommodating growing numbers in IoT devices and volumes. Cost efficiency, as it is a pay-per-usage model, so that upfront infrastructure investments are low. Global reach, cloud services enables you to reach globally. Why? Because cloud server is utilized by n number of people in the world. Rapid development, pre-built services and tool are going to accelerate the development time. Data management, cloud platforms are going to offer you an efficient storage and process of data analysis capability. Security, cloud provides invest heavily in security measures. And what kind of key cloud services are there? As I told you, cloud is going to provide three major services: IaaS, infrastructure as a service, and platform as a service, PaaS, and also SaaS, software as a service. These are the three services. IaaS, which provides virtual server, storages, network resources for building customized IoT solutions. And coming to platform as a service, it is going to offer you both development and deployment environments for IoT applications. And coming to SaaS, software as a service, which delivers you a complete IoT solutions as a service, which requires a minimal IoT involvement. These are the three major key cloud services which are provided. And what are the different popular cloud platforms which are there in IoT? AWS IoT, which offers device management, data ingestion, and analytical services. Azure IoT Hub, which is second one, which provides secure and reliable bidirectional communication between the IoT devices and cloud applications. Google Cloud IoT Core, which enables a secure and scalable connections for IoT devices. IBM Watson IoT, which focus on cognitive computing and data analytics for IoT solutions. These are the popular. And what are the challenges? Data privacy and security. Why? Because sensitive IoT data is very crucial, so you need to protect it. And coming to the network connectivity, which ensures a reliable connectivity for IoT devices. Data volumes and velocity, where we are handling a large amount of data for real-time data efficiency is a challenge. Interoperability, we need to interrogate the IoT devices and systems from different vendors which are going to be complex. These are the challenges which we are facing in cloud IoT. With that, I can conclude one thing, guys. By knowing about this particular cloud for IoT, these are going to give you a power of cloud computing for the organizations which are effectively building and deploying and managing the IoT services are going to overcome the challenges along with the traditional IoT infrastructure. And coming to the third point, third topic, which is Python Web Application Framework. We need to understand the role of this particular framework. This framework is a collection of modules and tools which provides a structure for developing the web application of services. Here, this particular framework is going to handle the underlying complexities of web development, which allows the developers to focus on application logic rather than reinventing the wheel. That is what the role of this particular Python web application framework. The key features for this framework is routing. It is going to handle the incoming requests and maps them to appropriate functions. Templating, which provides mechanism for generating HTML or content dynamically. Database integration, which offers tools for interacting with databases. Session management, which manages user sessions and data across requests. Form handling, which provides utilities for processing HTML forms. Security features, which includes built-in security measures to protect applications. And what are the different kinds of frameworks which are existed in popular Python web frameworks? Django, Flask, Pyramid. These are the popular Python web frameworks which are available in the market. Coming to Django, it was a high-level full-featured framework which emphasizes the rapid development and clear design. It has a strong ORM, which is object relational mapper for database interaction, and also it is having a built-in features for authentication, authorization, and admin interface. Coming to Flask, which is a micro framework which offers flexibility and simplicity, where it having a core components which can easily extendable with additional libraries which are suitable for small to medium sized projects. Coming to Pyramid, which is a third popular Python web framework, which is versatile framework with a focus of flexibilities and performance, which can be utilized for small to large scale applications, which offers you granular control over the application structure. So there are popular Python web frameworks such as Django, Flask, and Pyramid. And coming to other frameworks such as Bottle, Tornado, Fast API, these are Bottle was a minimal micro framework. Tornado, which is asynchronous framework for high performance applications. Fast API, which is a moderate high performance framework for building APIs. We need to know how to choose a proper framework according to your project requirement. You need to know the project size and complexity. For small projects, Flask and Bottle might surface, while Django and Pyramid are suitable for larger applications. And coming to performance needs, Tornado is ideal for high performance applications. And coming to team expertise, the framework should be aligned with the team skill set also. If there was a team which they doesn't know about Django and Pyramid, they only know about Flask and Bottle, then obviously team should be expertise on that particular framework which they are choosing while developing a IoT project. For that purpose, we also consider the features which are going to be considered for offering each kind of framework very easily. These are the things which we need to choose when selecting a right framework for our purposes. And coming to integration, with IoT. And here, these frameworks are used to build web applications for interacting with IoT design. The integration with IoT was done with data collection, data visualization, device control, API endpoints. Coming to data collection, the collected data from IoT devices are going to store in database. Device visualization. We are creating dashboards and visualization to monitor the IoT data. And coming to device control, which allows user to control the IoT devices through a web service interface. API endpoints, we are going to expose the API IoT data functionalities through RESTful APIs. By effectively utilizing these frameworks, developers are able to create robust and scalable IoT solutions, guys. And the last topic, which is designing RESTful web API. You need to understand this RESTful web API was. A RESTful API is an architectural style for designing network application, guys. Here we are using HTTP methods such as get, post, put, delete. These are the methods which are utilized in this particular architecture for manipulating the data and relies on the stateless communication protocol. What are the key principles which are existed in RESTful APIs? Those are resources, which represents the data for identifying the URLs. Stateless. Each request contains all necessary information. No session data is going to be stored in server. Catchability, where responses can be cached to improve performance. Uniform interface, which uses standard HTTP methods for CRUD operations such as create, read, update, delete operations. Layered system, client and server will have intermediaries. And code on demand, which is an optional, but it can be used to extend the client functionality also. These are the key principles which are existed in RESTful API. How this particular designing will be done by basing on four factors, guys. We need to identify the resources. For identifying the entities or data objects which should be managed by using API, we need to define URI. What URI are, which should be a clear and consistent URLs are used for accessing resources. And HTTP methods, I already told you, get, post, put, patch, delete. Get is used for retrieving a resource, post is used for creating a resource, and put is used for updating an entire resource. Patch is used for updating specific parts of a resource. Delete is used for deleting a resource. These are the HTTP methods which are used for get, put, post, patch, delete, and designing responsive formats by using JSON or extendable markup language for data representation purpose. These are the four things which are used in designing RESTful APIs. And along with this, there are some more things which are very helpful for implementing error handling, which provides informative errors with appropriate HTTP codes. Versioning, consider what version has to be utilized, considering the security, implement authentication, authorization, and data protection. Documentation, you should be clear while comprehensive the API documentation. What are the best practices which should be taken care of in REST API? Consistency, simplicity, performance, security, usability. Consistency, where we need to maintain the consistency by naming the conventions and response. Simplicity, you need to keep API design as simple as possible. Performance, we need to optimize API response for speed and efficiency. Security, you need to prioritize the data protection and authentication. Usability, a design API with user experience in mind. These are the things which should be taken care of for a best practice. I'll let you know with a small example how to design a sample block by using API. The resources are required: post, comments, users, URLs, posts, post ID, comments, comment ID, user ID. These are the best examples, guys. What are the HTTP methods? Get, for retrieving posts, retrieving comments or information. Post, to create a new post or comments. Put, to update the entire post or comment. Patch, which is used for updating specific field of a post or on a comment. Delete, delay post or comment. These are the things which has to be initiated in HTTP methods. What are the challenges and considerations which are faced when overfetching? To avoid the returning unnecessary data. Underfetching, which ensures client to retrieve the required data efficiently. API versioning, which manages the API without breaking existing clients. Security, to protect against common vulnerabilities like injection, authentication, failures, and data exposure. performance, which optimize to respond the scalability. With this, I can conclude you guys. You guys have known about these four things very detailed. That was the end of presentation. With this, you guys are capable of knowing about these things very efficiently. Thank you guys. We'll meet in the next class.
Like, share, and subscribe. Hit the bell icon for more updates.